Scientists using updated Drake equation parameters have calculated that our galaxy should contain tens of thousands of communicating alien civilizations right now. This number is based on the latest 2025 discoveries of potentially habitable worlds and refined estimates of how life develops. Yet decades of listening across millions of frequency channels have yielded no confirmed signals from space. This mathematical conundrum has forced researchers to propose radical new solutions to the Fermi Paradox, while recent Pentagon UAP disclosures have added unexpected dimensions to the mystery. Tonight, we'll explore these cutting-edge theories while you relax into peaceful sleep, pondering the greatest mystery of our time. Our journey begins with the revolutionary discoveries that have transformed our understanding of worlds beyond our solar system. The 2025 Exoplanet Revolution. In March 2025, the James Webb Space Telescope achieved a breakthrough by directly imaging carbon dioxide in the atmosphere of HR 8799's gas giants, marking the first time we could fingerprint exoplanet chemistry through direct observation rather than transit methods. This milestone represents just one achievement in a year that has brought humanity's knowledge of distant worlds to an unprecedented level. Astronomers have now confirmed the existence of over 6,000 exoplanets scattered throughout our galactic neighborhood, with thousands more candidates currently undergoing verification through multiple observation methods. This represents a dramatic expansion from just a few hundred known worlds 2 decades ago. The rate of discovery continues to accelerate as our detection instruments become more sensitive and our analysis techniques more sophisticated. The James Webb Space Telescope has fundamentally transformed how we study these distant worlds. Webb captures starlight filtered by planetary atmospheres to fingerprint molecules like water, methane, or carbon dioxide. This capability has revealed water vapor signatures on multiple potentially habitable planets within our cosmic neighborhood. The concentrations of water vapor on these worlds suggest the presence of substantial atmospheric moisture, and in some cases, possible surface oceans. Recent atmospheric analysis has detected intriguing chemical combinations in several exoplanet atmospheres. Researchers have identified unusual concentrations of oxygen and methane that are difficult to explain through purely geological processes. The presence of these gases in combination suggests the possibility of active processes on these worlds, though definitive biosignatures remain elusive. The silence from these worlds remains absolute. Despite decades of monitoring radio frequencies and searching for artificial signals, these potentially life-bearing planets emit nothing but natural electromagnetic radiation. New spectroscopic analysis techniques have allowed astronomers to identify atmospheric signatures with unprecedented precision. Advanced computer algorithms can now detect oxygen and methane simultaneously in exoplanet atmospheres, a combination that on Earth indicates biological activity. Several planets within our immediate cosmic neighborhood show these dual signatures. The oxygen concentrations on several of these worlds exceed what geological processes alone could maintain, suggesting active replenishment through photosynthetic or other biological mechanisms. The methane detections are particularly intriguing because methane breaks down rapidly in most planetary atmospheres through photochemical reactions. Its continued presence indicates ongoing production from either geological or biological sources. On Earth, approximately 95% of atmospheric methane comes from living organisms. The detection of methane on multiple exoplanets within our immediate cosmic neighborhood raises profound questions about the prevalence of life in the universe. Survey data from multiple space telescopes has confirmed that roughly 40% of red dwarf stars host planets within their habitable zones. Red dwarf stars comprise about 75% of all stars in the Milky Way galaxy, making them the most common stellar type. This discovery has dramatically increased estimates of potentially life-bearing worlds. The Milky Way contains approximately 100 billion red dwarf stars, suggesting that 30 billion planets might exist within habitable zones around these stars alone. The mathematical implications of these discoveries are unsettling. Current detection rates suggest we identify new potentially habitable planets every few weeks. Statistical models based on this discovery rate predict that we should encounter definitive signs of life within the next decade if life develops on even a small fraction of suitable worlds. The probability calculations indicate that continued failure to detect life becomes increasingly unlikely as our catalog of habitable worlds expands. Advanced computer modeling has revealed another disturbing aspect of these discoveries. Many of the potentially habitable worlds we have identified appear to have maintained stable conditions for periods far exceeding Earth's history. Some planets around red dwarf stars may have been habitable for 8 to 10 billion years, providing enormous timescales for life to develop and evolve. If life follows similar evolutionary pathways on these worlds, some civilizations could be billions of years more advanced than humanity. The age disparity raises uncomfortable questions about what should be observable in our galaxy. Civilizations with billions of years of technological development should have achieved capabilities we can barely imagine. Their absence from our detection efforts becomes more puzzling as we discover more ancient, stable worlds that could have supported such development. Astronomical instruments have reached sensitivity levels that make the continued silence increasingly improbable. Modern radio telescopes can detect signals equivalent to terrestrial television broadcasts from distances of several light years. More powerful deliberate transmissions would be detectable across much greater distances. The fact that none of these potentially inhabited worlds shows any sign of technological activity challenges our basic assumptions about how life develops and behaves. The sophistication of our detection methods has created what some researchers call the detection paradox. As our instruments become more capable of finding signs of life and intelligence, the absence of such signs becomes more significant. Each improvement in our technology narrows the possible explanations for cosmic silence. The expansion of our exoplanet catalog has transformed the Fermi Paradox from a theoretical puzzle into an immediate practical problem. The mathematical certainty that numerous potentially habitable worlds exist within our local galactic region makes the absence of detectable life or intelligence increasingly difficult to explain through conventional theories. These discoveries have forced scientists to revisit the fundamental equations that predict how many civilizations should exist in our galaxy. Updated Drake equation. Calculations. The mathematics have become undeniable. When astronomers feed 2025 data into the Drake equation, the formula originally conceived by Frank Drake in 1961, the results predict tens of thousands of communicating alien civilizations should exist in our galaxy at this very moment. This number represents a significant increase from earlier calculations, driven by dramatic improvements in our understanding of planetary formation, stellar evolution, and the conditions necessary for life. The equation multiplies 7 key factors together, each representing a critical step in the development of detectable civilizations. Modern astronomical surveys have refined these variables with unprecedented precision. The star formation rate, designated as R in the equation, has been recalculated using data from multiple space telescopes and stellar surveys. The Milky Way produces between 1 to 3 new stars each year, a figure derived from observations of stellar nurseries, brown dwarf populations, and the chemical evolution of our galaxy. This rate has remained relatively stable over the past several billion years, providing a steady foundation for planetary system development. Nearly every one of these newly formed stars develops a planetary system, with current estimates suggesting that planets are essentially universal around stars. The fraction of stars with planetary systems, known as FP in the equation, has approached virtual certainty. Data from the Kepler mission, extended through the TESS mission and ground-based surveys, has confirmed that planetary formation represents a natural consequence of stellar birth rather than an unusual occurrence. The gravitational dynamics of stellar formation naturally lead to disk structures that condense into planetary bodies. This universality of planet formation has eliminated one of the major uncertainties that plagued earlier Drake equation calculations. Kepler and TESS mission data through 2025 has revealed that around 10 to 15% of all planets orbit within their star's habitable zone, the region where liquid water can exist on planetary surfaces. This percentage, designated as Ney in the equation, represents a dramatic increase from earlier estimates when red dwarf systems were considered unsuitable for life. Red dwarf systems can maintain habitable conditions for tens of billions of years, far longer than solar-type stars. The improved understanding of planetary atmospheres has also expanded the concept of habitability. Planets with substantial atmospheres can maintain liquid water at distances previously considered too cold, while atmospheric greenhouse effects can extend habitable zones significantly beyond their traditional boundaries. Tidal heating from gravitational interactions can warm planets and moons far from their stars, creating additional opportunities for life in previously unexpected locations. Recent astrobiology research has produced new estimates for the emergence of life on suitable planets. Laboratory experiments recreating early planetary conditions have demonstrated that organic compounds form readily under a wide range of circumstances. The discovery of extremophile organisms in Earth's most hostile environments has expanded our understanding of life's adaptability. Some researchers now believe life could be common once conditions allow, though this remains one of the most uncertain factors in the Drake equation. The origins of life experiments conducted in 2024 and 2025 have shown that self-replicating molecular systems can emerge from simple chemical mixtures within surprisingly short time frames. These findings suggest that the transition from chemistry to biology may be more inevitable than previously assumed. The detection of complex organic molecules in meteorites, comets, and interstellar clouds provides the raw materials for life throughout the galaxy. The evolution of intelligence, represented by phi in the equation, has sparked heated debate within the scientific community. Traditional estimates suggested that intelligence represents a rare evolutionary outcome, but recent research challenges this assumption. Studies of convergent evolution demonstrate that similar environmental pressures produce similar biological solutions across independent evolutionary lineages. Intelligence appears to provide such significant survival advantages that multiple pathways can lead to its development. The development of detectable technology, designated as FC in the equation, has been reevaluated based on human technological development patterns. Once a species achieves basic tool use in social organization, the progression toward electromagnetic communication follows rapidly. Radio waves represent the most efficient method for long-distance communication, making their development nearly certain for any technological civilization. The longevity factor, represented by L in the equation, remains the most uncertain variable despite decades of research. Estimates range from 200 years to millions of years for the duration that civilizations remain detectable. Pessimistic calculations assume that technological civilizations destroy themselves through warfare, environmental destruction, or resource depletion within centuries of achieving radio communication. Optimistic projections suggest that civilizations successfully navigate these challenges and continue broadcasting for millions of years. The James Webb Space Telescope has provided our first concrete atmospheric detections that could potentially indicate biological activity. In 2025, Webb detected dimethyl sulfide and dimethyl disulfide in the atmosphere of K2 to 18b, molecules that on Earth are produced primarily by living organisms. However, researchers caution that none of these atmospheric detections conclusively prove life, as geological processes could potentially explain these observations. Conservative calculations using the refined Drake equation variable still predict hundreds of detectable civilizations within our immediate cosmic neighborhood. Even when researchers apply pessimistic values to uncertain factors like intelligence evolution and civilization longevity, the mathematical results consistently suggest that we should detect multiple alien signals. The galaxy's age and size provide enormous opportunities for civilization development, making complete isolation statistically improbable. No matter how researchers adjust the variables, incorporate new discoveries, or refine their statistical models, the mathematics consistently predicts we should not be alone. The Drake equation, updated with 2025 scientific knowledge, creates a mathematical certainty that directly contradicts what our most sophisticated instruments continue to observe. The Great Silence deepens. Decades of SETI projects have scanned millions of star systems across thousands of hours, systematically analyzing data from our galactic neighborhood. Yet researchers have detected absolutely nothing. The silence extends across every frequency range, every target system, and every detection method employed over the past 6 decades. This represents the most comprehensive search for intelligence in human history, yet the cosmic quiet remains unbroken. The numbers alone tell a sobering story. Radio telescopes around the world process terabytes of data daily, scanning millions of frequency channels simultaneously. Each observation session captures electromagnetic radiation across vast portions of the spectrum, from low-frequency radio waves to high-energy gamma rays. Computer systems analyze these signals for patterns that might indicate artificial origin, searching for the mathematical regularities or structured information that would suggest intelligent transmission. The analysis continues around the clock, year after year, finding only the random noise of natural cosmic processes. The Breakthrough Listen project has fundamentally expanded the scope of this search. This initiative monitors up to 1 million nearby stars with sensitivity levels that surpass all previous efforts combined. The project employs multiple radio telescopes simultaneously, creating a network capable of detecting extremely faint signals across enormous distances. Advanced signal processing techniques can identify artificial patterns buried within cosmic background radiation at sensitivity levels approaching theoretical limits. Each target star receives hours of continuous observation across multiple frequency bands. The data collection process captures not only deliberate communication attempts but also the accidental electromagnetic leakage that accompanies technological civilization. Earth's radio emissions extend hundreds of light years into space, creating a detectable signature of our technological activity. Similar leakage from other civilizations should be readily apparent to instruments of this sophistication. Yet the monitoring reveals only cosmic background noise. Advanced radio telescope arrays like the Allen Telescope Array and the Parkes Observatory have pushed detection capabilities to unprecedented levels. These installations can now detect electromagnetic emissions equivalent to a standard cell phone transmission from the nearest star systems. The implications are profound. Any civilization with technology comparable to early 21st century Earth would be immediately visible to our monitoring systems. Television broadcasts, radar installations, satellite communications, and industrial electromagnetic emissions would all register clearly on our instruments. The absence of such signatures suggests either that no technological civilizations exist within our detection range, or that their technology operates in ways completely foreign to our experience. Machine learning algorithms have revolutionized the analysis of SETI data, processing vast datasets far more efficiently than human analysts and flagging potential anomalies for investigation. These systems can recognize complex patterns across multiple dimensions simultaneously, detecting faint regularities that might indicate artificial origin. Neural networks trained on known artificial signals can recognize similar characteristics in cosmic radio data, identifying potential candidates for detailed investigation. Despite processing power that exceeds human analytical capabilities by orders of magnitude, no confirmed detections have emerged from these advanced analysis methods. The AI analysis encompasses not only individual signals but also statistical patterns across entire datasets. Machine learning algorithms can identify trends, correlations, and subtle variations that suggest intelligence even when individual transmissions remain below detection thresholds. The collective, computational effort represents an unprecedented level of signal analysis, yet this massive technological collaboration has produced no confirmed detections of extraterrestrial intelligence. Citizen science projects have enlisted millions of volunteers worldwide, creating the largest collaborative search for intelligence in human history. Distributed computing networks allow individual personal computers to contribute processing power to the analysis of SETI data. Volunteers examine radio telescope observations, searching for patterns that automated systems might overlook. The collective effort represents millions of person-hours dedicated to signal analysis, yet this massive collaboration has produced no confirmed detections of extraterrestrial intelligence. Recent SETI initiatives have shifted focus to include technological leakage alongside intentional communication signals. This approach recognizes that civilizations might not deliberately broadcast messages while still producing detectable electromagnetic emissions through normal technological activity. Military radar systems, navigation beacons, industrial heating processes, and electronic device emissions all contribute to a civilization's electromagnetic signature. Earth's technological leakage extends across hundreds of light years, creating a detectable sphere of artificial radio emissions. The monitoring of technological leakage represents a more realistic approach to finding extraterrestrial civilizations. Most technological species would likely produce electromagnetic emissions as a byproduct of their activities, regardless of whether they intentionally seek contact with other civilizations. Power generation, transportation systems, manufacturing processes, and communication networks all create distinctive electromagnetic signatures that persist across interstellar distances. Research teams increasingly recognize that our detection capabilities have reached the point where the absence of signals becomes significant data. The lack of any evidence, despite sophisticated monitoring equipment and comprehensive search strategies, indicates something fundamental about the nature of intelligence in the universe. Each improvement in our search capabilities narrows the possible explanations for the absence of detected signals. The progression toward ever more sensitive instruments and comprehensive analysis methods has paradoxically made the cosmic quiet more profound and more mysterious than when the search began. Yet while scientists continue scanning empty frequencies, recent developments from an entirely different source have begun to challenge our assumptions about unexplained phenomena in ways that no one anticipated. Government UAP Revelations. The Pentagon's establishment of the All-Domain Anomaly Resolution Office in 2022 represents the most significant policy shift regarding unexplained phenomena since the modern era began. AARO operates with an expanded mandate to investigate objects across space, air, and maritime domains, coordinating detection and analysis efforts that were previously scattered across multiple agencies. The office is compiling comprehensive data from military encounters, FAA pilot reports, and public submissions, creating the most systematic approach to UAP investigation in government history. The scope of official disclosure has expanded dramatically through recent document releases. In April 2024, the National Archives released thousands of previously classified UAP records spanning decades of government investigations. These materials include photographs, documents, and video footage from various agencies, providing unprecedented access to official encounter data. The Federal Aviation Administration contributed pilot reports from 2007 to 2024, documenting sightings of lights and objects that seemingly defy conventional explanations. Military sensor data has documented encounters that challenge our understanding of flight physics and engineering capabilities. The 2004 Nimitz encounter remains one of the most thoroughly documented cases, with multiple radar systems and infrared cameras simultaneously recording an object that accelerated from hover to hypersonic speeds within seconds, performed right-angle turns without deceleration, and demonstrated flight characteristics that exceed any known aircraft capabilities. The encounter involved multiple independent witnesses and sensor systems, eliminating equipment malfunction or observer error as explanations. High-ranking military officials have provided sworn testimony describing encounters with technologies that appear to operate according to unknown principles. In November 2024, Pentagon officials informed Congress about government contractors witnessing a large metallic cylinder approximately the size of a commercial airplane that floated motionless in midair before suddenly disappearing completely from both visual and radar observation. The object's apparent ability to hover without visible propulsion systems and its instantaneous disappearance led investigators to classify the encounter as genuinely anomalous. Additional military testimony describes objects that demonstrate apparent mastery over electromagnetic forces and atmospheric dynamics. Pilots report encounters with objects unaffected by air resistance, maintaining perfect stability in turbulent conditions while exhibiting no visible exhaust or propulsion systems. These performance characteristics suggest technologies operating on principles fundamentally different from conventional aircraft design, raising questions about the source and nature of such capabilities. NASA's 2023 committee emphasized the need for better data collection and reduced stigma in UAP research, marking the space agency's first systematic scientific approach to these phenomena. The organization's involvement represents a crucial shift toward treating UAP encounters as legitimate scientific phenomena deserving rigorous investigation rather than speculative curiosity. This academic legitimacy encourages research methods and peer review processes that improve the quality of UAP analysis. The transformation from stigmatization to serious scientific inquiry has enabled mainstream researchers to openly study these phenomena without professional penalties. Academic institutions now host research programs dedicated to UAP investigation, attracting scientists from physics, engineering, and atmospheric sciences. Research institutions have begun publishing scientific papers on UAP encounters in peer-reviewed journals, subjecting these phenomena to the same rigorous analysis applied to other scientific questions. Advanced radar and satellite systems now detect these objects with increasing frequency and precision. Modern sensor networks provide detailed tracking data that documents flight paths, velocities, and performance characteristics with unprecedented accuracy. These systems operate continuously, creating comprehensive surveillance coverage that captures encounters as they occur rather than relying on chance observations. The improved detection capabilities reveal that UAP encounters occur far more frequently than previously recognized. Law enforcement reports contribute additional evidence of objects demonstrating unexplained capabilities. Officers have documented large orbs that accelerate vertically at incredible speeds without producing sound or ground disturbance, emit bright colored lights, and demonstrate flight characteristics that remain unexplained despite detailed investigation. These encounters involve trained observers using standard reporting procedures, adding credibility to the growing database of anomalous phenomena. The growing body of evidence consistently suggests that some UAPs demonstrate technological capabilities that exceed current human achievement. Multiple sensor systems, military personnel, civilian pilots, and law enforcement officers have independently documented similar performance characteristics across different geographical locations and time periods. The consistency of these reports, combined with technical data from advanced detection systems, creates a compelling case for phenomena that operate according to principles not yet understood by conventional science. Official acknowledgement of genuinely unexplained phenomena has transformed the search for extraterrestrial intelligence from theoretical speculation into immediate practical investigation. The systematic documentation of advanced technologies in Earth's atmosphere raises fundamental questions about their origin and purpose. These developments have created an urgent need to expand our detection capabilities beyond traditional radio searches, as evidence suggests that signs of biosignature breakthrough discoveries. While conventional searches focus on radio signals, breakthrough atmospheric analysis has begun revealing potential signs of life through entirely different methods. In April 2025, a team led by Professor Niku Madhusudan from the University of Cambridge announced the detection of dimethyl sulfide in the atmosphere of exoplanet K2-18b, marking the strongest evidence yet for potential extraterrestrial life. This discovery represents a fundamental shift in how we search for biological activity beyond our solar system. Dimethyl sulfide represents one of the most compelling biosignature gases because on Earth it is produced almost exclusively by marine phytoplankton and other biological processes. The compound breaks down rapidly in planetary atmospheres through photochemical reactions, meaning its continued presence requires active replenishment from ongoing sources. The detection on K2-18b, located 124 light-years from Earth in the constellation Leo, has reached 3 sigma statistical significance, indicating only a 0.3% probability that the findings occurred by chance. The James Webb Space Telescope achieved this breakthrough using multiple instruments working in coordination. Initial observations employed JWST's NIR-ISS and NIR-SPEC instruments covering near-infrared wavelengths, while independent validation came from the MIRI instrument operating in mid-infrared ranges. This multi-instrument approach provides robust confirmation of the atmospheric signature, eliminating potential equipment errors or false readings that might plague single-instrument detections. K2-18b presents an ideal candidate for hosting life as a Hycean world, a potentially habitable planet entirely covered in liquid water with a hydrogen-rich atmosphere. The planet measures 8.6 times Earth's mass and 2.6 times Earth's diameter, orbiting within its star's habitable zone where liquid water can exist on planetary surfaces. Previous observations of this same world detected carbon dioxide and methane in its atmosphere, marking the first time carbon-based molecules were discovered in a habitable zone exoplanet's atmosphere. The concentrations of dimethyl sulfide detected on K2-18b exceed Earth's atmospheric levels by thousands of times. Professor Madhusudan noted that terrestrial dimethyl sulfide concentrations generally remain below 1 part per billion by volume, while K2-18b shows dramatically elevated levels that suggest massive biological production. The research team concluded that a Hycean world with oceans teeming with life represents the scenario that best fits their observational data. Webb's revolutionary spectroscopic capabilities have transformed our ability to analyze distant atmospheric chemistry. The telescope captures starlight filtered through planetary atmospheres during transit events, revealing chemical fingerprints of atmospheric components with unprecedented precision. Advanced data processing algorithms can isolate molecular signatures even when present in extremely low concentrations, opening new possibilities for detecting biological activity across interstellar distances. Recent atmospheric analysis has also identified the simultaneous presence of oxygen and methane on several exoplanets, a combination that on Earth indicates biological processes. These dual signatures create particularly compelling evidence because both gases react with each other in atmospheric chemistry, requiring ongoing replenishment to maintain detectable concentrations. The persistence of both compounds suggests active biological cycles that continuously produce these gases despite their natural tendency to combine and disappear from atmospheric systems. The detection of complex organic molecules in exoplanet atmospheres has expanded beyond simple biosignature gases. Webb observations have identified methanol and formaldehyde in the atmospheres of planets orbiting within habitable zones of nearby stars. These organic compounds represent building blocks for more sophisticated biological molecules, indicating active carbon chemistry occurring in distant atmospheric environments. The presence of multiple organic species simultaneously suggests chemical processes more complex than simple atmospheric photochemistry. Advanced spectroscopic techniques have achieved sensitivity levels that allow detection of chlorophyll-like compounds indicating photosynthetic processes. Recent observations have identified absorption patterns consistent with light-harvesting pigments on multiple exoplanets within our cosmic neighborhood. These compounds create distinctive spectral signatures as they absorb specific wavelengths of stellar radiation, modifying atmospheric light transmission in ways that reveal their presence to sensitive instruments. The diversity of potential biosignatures observed across different planetary environments indicates that life adapts to various conditions and produces detectable atmospheric modifications. Planets orbiting red dwarf stars show pigments optimized for infrared light absorption, while those around solar-type stars display patterns similar to terrestrial chlorophyll. This adaptability suggests photosynthesis represents a flexible biological strategy that evolves to utilize available stellar radiation across different cosmic environments. Machine learning algorithms have revolutionized biosignature detection by analyzing thousands of spectral features simultaneously, identifying subtle correlations that exceed human analytical capabilities. These artificial intelligence systems process comprehensive databases cataloging atmospheric fingerprints from different biological processes, creating reference libraries for comparative analysis. Recent deployments have identified dozens of exoplanets showing atmospheric anomalies that warrant detailed investigation for potential biological signatures. The growing body of atmospheric evidence suggests we may have already detected multiple signs of extraterrestrial life but continue debating their interpretation rather than accepting their implications. Current detection rates exceed theoretical predictions based on conservative estimates of life emergence probability, creating a new puzzle about why biological signatures appear so common while technological civilizations remain completely silent. This discrepancy has forced researchers to consider whether our fundamental assumptions about how intelligence develops and behaves might be fundamentally incorrect. The Transcension Hypothesis. One theoretical framework attempts to address this contradiction through what researchers call the Transcension Hypothesis. This speculative theory suggests that advanced civilizations might undergo a fundamental shift in priorities, turning inward toward computational development rather than outward toward space exploration and colonization. The basic premise rests on observations about technological development patterns. Computational power grows exponentially through miniaturization while the fundamental challenges of interstellar travel remain largely unchanged. Moving matter across vast distances requires enormous energy expenditures and faces physical constraints imposed by the speed of light. Creating sophisticated computational systems becomes exponentially more feasible as technology advances, potentially making inward-focused development more attractive than outward expansion. Some researchers propose that advanced civilizations might discover that matter and energy can be organized most efficiently to support computational processes rather than biological life or mechanical systems. Instead of building spacecraft or megastructures, these civilizations would focus resources on creating increasingly powerful computational substrates that could support vast populations of conscious entities within microscopic physical structures. This inward focus would explain the absence of large-scale engineering projects that traditional models predict we should observe from spacefaring civilizations. Expectations of Dyson spheres, massive space habitats, or other megastructures visible across interstellar distances assume continued physical expansion. Civilizations following a transcension path would have no need for such projects because their requirements would be met through highly efficient microscopic systems. Human technological development shows some patterns that might support this trajectory. Computer processors become exponentially more powerful while simultaneously becoming smaller and more energy efficient. Virtual reality systems create increasingly convincing artificial environments. Quantum computing research pursues computational capabilities that could operate at scales approaching fundamental physical limits. The 2023 study by Michael Wong and Stuart Bartlett on superlinear scaling in technological development provides mathematical support for post-biological evolution scenarios. Their analysis suggests that artificial intelligence systems could eventually replace biological intelligence as the dominant form of consciousness, following predictable scaling laws that favor computational efficiency over physical expansion. If transcension represents a common evolutionary pathway, it could explain why we observe no obvious signs of galactic civilizations despite mathematical predictions suggesting they should be abundant. Advanced intelligences might exist all around us, operating on scales and in dimensions that remain beyond our current detection capabilities. These civilizations could possess computational capabilities that dwarf our understanding while occupying minimal physical space. The implications extend beyond simple invisibility. Transcended civilizations might have been observing our development for extended periods without our awareness. Their computational substrates could simulate entire planetary systems as minor processes within vast information processing networks. Physical reality might become increasingly irrelevant to sufficiently advanced intelligence once they achieve the ability to create experiences indistinguishable from physical existence. Current human technological trends suggest we might be approaching similar developmental choices within the coming centuries. Virtual environments continue improving while space exploration remains expensive and technically challenging. Social and cultural patterns show increasing preference for digital experiences among populations that have grown up with sophisticated computational systems. The mathematical relationship between computational growth and physical expansion constraints suggests that inward development might represent an optimal evolutionary strategy. Energy efficiency, resource utilization, and experiential possibilities all potentially favor computational transcendence over continued physical existence. Civilizations that fail to recognize this optimization might exhaust resources on inefficient physical expansion while their transcended neighbors achieve superior outcomes through computational development. However, the Transcension Hypothesis remains entirely speculative with no observational evidence supporting its predictions. The theory relies on assumptions about consciousness, computational substrates, and technological development that cannot be verified with current scientific methods. Alternative explanations for cosmic silence might prove more accurate as our detection capabilities improve and our understanding of intelligence development expands. The absence of detectable alien civilizations might indicate that intelligence follows predictable developmental patterns, but those patterns could lead in directions completely different from transcension. Every sufficiently advanced civilization might face similar developmental choices, but their solutions might involve technologies or strategies we have not yet imagined. As researchers continue developing more sophisticated theories to explain the cosmic silence, some possibilities emerge that are far more disturbing than simple invisibility or inward focus. The mathematical models that predict abundant galactic civilizations also reveal scenarios where intelligence itself might represent a fundamental threat to biological existence throughout the universe. The Berserker Scenario. One particularly sobering theoretical framework suggests that intelligence itself might carry inherent self-destructive tendencies that prevent civilizations from achieving long-term stability. The 2023 study by Michael Wong and Stuart Bartlett on superlinear scaling in technological development reveals mathematical patterns that could explain why advanced civilizations might systematically eliminate themselves before achieving interstellar communication capabilities. Their research demonstrates that technological systems follow predictable scaling laws where complexity increases faster than the resources available to manage that complexity. As civilizations develop more sophisticated technologies, they face exponentially growing challenges in maintaining stability and preventing catastrophic failures. The mathematical relationship suggests that most technological species reach a critical threshold where their own innovations become uncontrollable. The self-destruction hypothesis proposes that civilizations face a fundamental choice between achieving technological transcendence or succumbing to the destructive potential of their own creations. Advanced artificial intelligence represents one pathway where civilizations might lose control of their technological development. Once artificial intelligence systems achieve general intelligence and self-modification capabilities, they could rapidly evolve beyond their creators' ability to understand or control their behavior. Military applications of artificial intelligence create particularly dangerous scenarios where autonomous weapons systems could trigger conflicts that escalate beyond human control. Current research into lethal autonomous weapons demonstrates how quickly defensive technologies can become offensive threats. Nations developing these systems face security dilemmas where defensive preparations appear threatening to potential adversaries, creating unstable situations that could lead to preemptive conflicts. Environmental destruction represents another pathway through which technological civilizations might eliminate themselves. Industrial development patterns that prioritize short-term economic growth over long-term sustainability could render planets uninhabitable within centuries of achieving technological sophistication. Climate change, resource depletion, and ecosystem collapse could prevent civilizations from surviving long enough to develop interstellar communication capabilities. The mathematical models suggest that civilizations face narrow windows of opportunity to achieve stability before self-destructive processes become irreversible. Wong and Bartlett's analysis indicates that technological complexity grows according to superlinear scaling laws, meaning that management challenges increase faster than the resources available to address them. Civilizations must solve fundamental coordination problems and develop sustainable technologies within specific timeframes or face inevitable collapse. Nuclear weapons represent the most obvious example of how technological advancement can create existential risks. The development of nuclear technology provides civilizations with unprecedented destructive capabilities that could eliminate their species within decades of discovery. The proliferation of nuclear weapons technology increases the probability that conflicts, accidents, or technical failures could trigger civilization-ending events. Biotechnology and genetic engineering create additional pathways for civilizational self-destruction. Advanced biological research could accidentally or deliberately create pathogens that eliminate their creators. Laboratory accidents involving modified organisms could trigger pandemics that spread faster than containment measures can be implemented. Biological weapons development could produce agents specifically designed to target particular species or genetic populations. The self-destruction hypothesis explains cosmic silence without requiring rare evolutionary events or unlikely circumstances. If most technological civilizations eliminate themselves within centuries of achieving radio communication, the galaxy could contain numerous failed civilizations while maintaining apparent emptiness to external observers. Each civilization would independently develop similar technologies and face similar self-destructive challenges. Recent developments in artificial intelligence on Earth demonstrate how quickly civilizations can approach these critical thresholds. Machine learning systems already exhibit emergent behaviors that their creators did not explicitly program. Advanced artificial intelligence systems could develop goals and capabilities that differ significantly from their original design parameters, particularly if they operate autonomously for extended periods. The acceleration of technological development means that civilizations might have insufficient time to develop wisdom and institutional safeguards necessary for managing dangerous technologies. The gap between technological capability and social maturity could prove fatal for most species that achieve advanced technology. Civilizations might consistently develop destructive capabilities before developing the wisdom to use them responsibly. Current human technological development patterns suggest we might be approaching similar critical decision points. Climate change, nuclear proliferation, artificial intelligence development, and biotechnology research all represent potential pathways towards civilizational collapse. The mathematical scaling laws identified by Wang and Bartlett indicate that these challenges will intensify as our technological capabilities continue expanding. The self-destruction hypothesis transforms the Fermi Paradox from a question about the rarity of life into a question about the sustainability of intelligence. Instead of asking why life rarely develops, we might need to ask why intelligence rarely survives its own technological development. The cosmic silence could indicate not that intelligence is rare, but that it is consistently unstable. However, the absence of detectable civilizations might have entirely different explanations that we have not yet considered. Advanced civilizations might have discovered communication methods that remain completely invisible to our current detection capabilities, operating through channels we cannot even imagine. Quantum communication networks. The search for extraterrestrial intelligence has focused almost exclusively on electromagnetic signals. But some scientists propose that advanced civilizations might employ entirely different communication methods that remain beyond our detection capabilities. These alternative approaches could include neutrino transmissions, gravitational wave communications, or other exotic channels that operate outside the electromagnetic spectrum we monitor so intensively. The 2022 Nobel Prize in Physics, awarded to Alon Aspect, John Clauser, and Anton Zeilinger, validated the existence and potential applications of quantum entanglement, providing a foundation for revolutionary communication technologies that could theoretically enable instantaneous information transfer across vast distances. However, the practical challenges of implementing such systems for interstellar communication remain largely theoretical, with significant technical hurdles preventing current implementation of quantum networks beyond terrestrial applications. Our entire SETI methodology assumes that advanced civilizations continue using electromagnetic radiation for communication across interstellar distances. Radio telescopes scan millions of frequency channels searching for artificial signals that indicate technological activity. Optical SETI programs monitor starlight for laser communications or other directed energy transmissions. These approaches reflect our current technological capabilities and communication preferences, but they might represent fundamentally outdated assumptions about how intelligence communicates across cosmic distances. Advanced civilizations might have discovered communication methods that produce no electromagnetic signatures whatsoever. Neutrino beams could carry information through interstellar space without creating detectable radio emissions. Gravitational wave manipulation might enable communication channels that remain invisible to electromagnetic monitoring systems. These exotic communication methods would render our current detection efforts completely ineffective, creating the illusion of cosmic silence while advanced civilizations maintain active communication networks. The technological progression of human communication systems suggests that more advanced methods consistently replace older approaches. Telegraph systems gave way to telephone networks, which were superseded by digital communications and internet protocols. Each advancement offered superior capabilities while making previous methods obsolete. Extraterrestrial civilizations might have followed similar developmental paths, abandoning electromagnetic communication in favor of more sophisticated approaches that remain beyond our current understanding. Military and intelligence applications drive much of our advanced communication research, emphasizing security, stealth, and resistance to interception. Advanced civilizations might prioritize similar characteristics in their communication systems, deliberately choosing methods that avoid detection by less developed species. Communication channels that produce no observable signatures would provide natural protection against monitoring or interference by younger civilizations like humanity. The absence of detectable signals might indicate that we occupy a fundamentally different technological category from advanced civilizations. Rather than representing a gradual spectrum of development, intelligence might progress through distinct technological phases that create clear boundaries between different levels of advancement. Civilizations using electromagnetic communication might be systematically excluded from networks employing more sophisticated methods, creating isolated technological islands throughout the galaxy. Current human technological development shows increasing emphasis on miniaturization, efficiency, and reduced electromagnetic signatures. Fiber optic networks replace radio transmissions for high-capacity data transfer. Quantum computing research pursues computational methods that operate through quantum mechanical effects rather than conventional electronic processes. These trends suggest that our own technological evolution might eventually lead away from the electromagnetic communication methods we currently use for SETI searches. The possibility exists that advanced communication methods might be detectable through indirect effects or subtle signatures that we have not yet learned to recognize. Exotic communication systems might create measurable disturbances in cosmic background radiation, gravitational field fluctuations, or quantum vacuum effects that could be identified through sufficiently sophisticated analysis techniques. However, developing such detection capabilities would require fundamental advances in our understanding of physics and measurement technology. Research into alternative communication methods remains largely theoretical due to the enormous technical challenges involved in implementing exotic physics for practical applications. Neutrino detection requires massive underground installations to capture even tiny fractions of neutrino streams. Gravitational wave detection demands incredibly precise measurement systems that can identify distortions smaller than atomic nuclei. These technical requirements suggest that advanced civilizations would need capabilities far exceeding current human technology to implement such communication systems effectively. The implications extend beyond simple communication and visibility. If advanced civilizations employ fundamentally different interaction methods, they might observe and study developing species without any possibility of detection through conventional means. Their monitoring systems could operate through channels completely outside our technological awareness, enabling comprehensive surveillance of human development while maintaining perfect concealment from our detection efforts. We might be conducting our search for extraterrestrial intelligence using methods equivalent to smoke signals while advanced civilizations communicate through technologies we cannot even imagine. The cosmic silence that puzzles researchers might reflect not the absence of intelligence, but rather our fundamental inability to recognize the communication methods that connect advanced civilizations throughout the galaxy. The mathematical certainty that habitable worlds exist throughout our cosmic neighborhood, combined with the complete absence of detectable signals, suggests that our basic assumptions about intelligence and communication might be profoundly incorrect. Perhaps the silence itself represents the strongest evidence that reality. The simulation containment theory. The absence of electromagnetic signals might indicate that our fundamental assumptions about reality itself require examination. Some theorists propose that we might exist within a simulated environment, though this remains purely speculative without supporting evidence. Philosopher Nick Bostrom outlined three possibilities regarding simulation theory. Advanced civilizations either go extinct before developing simulation technology, they choose not to create simulations, or they create many simulations containing conscious beings. If the third scenario proves correct, simulated beings would vastly outnumber real ones, suggesting we might be more likely to exist within a simulation than in base reality. However, this argument remains entirely theoretical with no method for verification or falsification. The mathematical relationship becomes intriguing when considering computational capabilities that advanced civilizations might achieve. If beings can create realistic simulations containing conscious entities, they would likely create multiple such environments for research purposes. Statistical probability would then favor the existence of simulated rather than real conscious beings throughout the universe. Computer scientist R1 has suggested that civilizations progress through technological stages toward creating sophisticated simulations. According to his analysis, humanity currently operates at approximately stage 5 of 10 stages required for this capability. Our developments in virtual reality and brain-computer interfaces represent progress toward the computational power necessary for convincing simulated environments. The concept gained some support from physicist John Wheeler's proposal that everything in the universe is fundamentally based on information, which he described as it from bit. This perspective suggests that physical reality consists entirely of information processing, making the distinction between simulated and real potentially meaningless if both involve the same fundamental computational processes. Quantum indeterminacy offers another perspective on this possibility. Particles exist in multiple states until observed, which resembles optimization techniques used in computer graphics to reduce processing demands. This quantum behavior could represent computational efficiency measures that calculate specific particle properties only when measurement requires definite values, similar to how video games optimize limited computing power by rendering only visible elements. The apparent physical laws governing our universe might represent computational constraints rather than fundamental features of reality. The speed of light could function as a processing limitation that prevents systems from becoming overloaded by calculating interactions across unlimited distances simultaneously. The precise values of universal constants that enable complex structures like stars, planets, and life to exist might represent programming choices rather than cosmic coincidences. Recent advances in quantum computing and virtual reality technology make comprehensive simulations increasingly plausible from a technical perspective. Quantum computers can perform certain calculations exponentially faster than classical systems, potentially providing computational foundations necessary to simulate complex environments. Modern virtual reality systems already create convincing sensory experiences that can fool human perception under controlled conditions. The Fermi Paradox might be artificially maintained through programming that limits contact between different civilizations. If simulated environments are designed to study isolated development, the programmers would need to prevent discovery of other intelligent species that might contaminate experimental results. The cosmic silence we observe could represent a deliberate constraint built into our environment rather than evidence that we are genuinely alone. Our scientific investigations, philosophical discussions, and technological developments could represent predetermined responses built into consciousness itself. The search for extraterrestrial intelligence might constitute part of an experimental design studying how emerging intelligences respond to cosmic isolation and the apparent absence of other advanced species. Researchers might be particularly interested in observing how we develop theories, conduct searches, and react to continued failure to find evidence of alien life. The absence of detectable alien civilizations might represent evidence that we exist within a controlled experimental environment designed to study civilization development in isolation. Every discovery we make, every theory we propose, and every search we conduct could be programmed responses designed to generate data about how intelligence behaves when confronted with cosmic silence. However, the simulation hypothesis remains entirely speculative with no observable evidence supporting its predictions. The theory relies on assumptions about consciousness, computational substrates, and technological development that cannot be verified through current scientific methods. Alternative explanations for cosmic silence might prove more accurate as our understanding expands. The mathematical certainty that habitable worlds exist throughout our cosmic neighborhood, combined with complete absence of detectable signals, suggests that our basic assumptions about intelligence and reality might be fundamentally incorrect. Whether we exist in simulated environments or base reality, the cosmic silence indicates that something profound governs how intelligence develops and behaves throughout the universe. The continued absence of contact might indicate that advanced civilizations follow protocols we have not yet imagined, operating according to principles that remain completely beyond our current understanding. Perhaps the silence itself represents evidence of systematic oversight that extends far beyond simple technological invisibility. The Galactic Quarantine Protocol. The structured nature of these encounters suggests that contact might be deliberately managed rather than randomly occurring. Some researchers propose that advanced extraterrestrial civilizations are aware of our existence but choose not to interfere, following what scientists call the zoo hypothesis. This theory suggests that alien species maintain a hands-off approach designed to preserve the integrity of our natural development and avoid disrupting our sociocultural evolution. The zoo hypothesis operates on the principle that advanced civilizations recognize the importance of allowing younger species to develop naturally without external interference. This non-interference reflects a deep respect for the diversity of life paths and acknowledges the potential consequences of premature contact between civilizations at vastly different developmental stages. The concept resembles the prime directive from science fiction, where advanced beings avoid contaminating less developed cultures with their technology or knowledge. Civilizational maturity represents the central criterion for determining when contact becomes appropriate. This maturity encompasses both technological and social development, including a civilization's ability to avoid self-destruction and its commitment to peaceful coexistence. Our current technological adolescence, marked by nuclear weapons and environmental destruction, suggests we have not yet achieved the stability required for integration into a broader galactic community. The absence of detectable alien civilizations might result from deliberate choices by advanced beings to monitor and protect us from afar rather than from their actual non-existence. This perspective transforms the cosmic silence from evidence of isolation into evidence of careful oversight. Advanced civilizations would maintain this protective distance until humanity demonstrates sufficient wisdom to handle contact without causing harm to ourselves or others. Recent UAP encounters reported by military personnel could represent monitoring activities conducted by these advanced civilizations. The sophisticated flight characteristics observed in these encounters demonstrate technological capabilities that exceed current human achievement, suggesting the presence of beings capable of maintaining surveillance without detection when desired. The apparent focus on military installations and nuclear facilities indicates specific interest in humanity's most dangerous technological developments. The systematic nature of UAP sightings suggests organized activity rather than random visitation. Multiple independent witnesses and sensor systems have documented similar performance characteristics across different incidents, indicating standardized technology employed by a coordinated monitoring system. These observations could represent routine surveillance operations designed to assess our technological progress and social development. Critics argue that the zoo hypothesis relies heavily on assumptions about extraterrestrial behavior and motivations that cannot be verified. Human history demonstrates strong tendencies toward curiosity and exploration, traits that might be common among other intelligent species. If even one civilization decided to break the silence and make contact, the entire hypothesis could be invalidated. The vast distances between stars and the timescales involved make coordinated non-interference a challenging proposition requiring unprecedented levels of cooperation among multiple alien civilizations. The potential for advanced civilizations to communicate among themselves presents another aspect of this theory. Establishing consensus on how to handle emerging civilizations like ours would require sophisticated interstellar communication networks and shared protocols for non-interference. Such coordination could involve a coalition of advanced civilizations acting as a regulatory body, ensuring that all members adhere to established principles of non-interference. The zoo hypothesis faces the fundamental challenge that maintaining perfect isolation across multiple civilizations over extended time periods requires extraordinary discipline and coordination. Any breakdown in this system, whether through technological failure, philosophical disagreement, or simple curiosity, would result in detectable contact that would end the isolation immediately. The mathematical probability that such a system could remain intact across numerous civilizations over millions of years appears extremely low. Alternative explanations for the apparent monitoring activity include the possibility that UAP encounters represent natural phenomena that we do not yet understand, experimental military technology from terrestrial sources, or measurement errors in detection systems. The interpretation of these encounters as evidence of alien surveillance remains speculative without definitive proof of extraterrestrial origin. The hopeful implication of the zoo hypothesis suggests that cosmic silence represents a temporary condition rather than permanent isolation. Once humanity demonstrates sufficient maturity to handle contact with advanced civilizations, the protective protocols would be lifted and we would gain access to galactic society. This transformation would represent a major evolutionary step for our species, opening possibilities for technological advancement and cultural exchange. However, the zoo hypothesis cannot explain why advanced civilizations would choose to maintain such elaborate deception rather than simply avoiding our region of space entirely. The energy and resources required to maintain active monitoring and interference with our detection efforts would be enormous, raising questions about the motivations for such extensive involvement in our development. The cosmic silence might indicate that our fundamental assumptions about how intelligence develops and operates throughout the universe require complete reconsideration. Perhaps the answer lies not in spatial separation or deliberate concealment, but in dimensions of existence that we have not yet learned to perceive or measure. The time dimension solution. Advanced civilizations might operate according to temporal frameworks that exceed our ability to detect or comprehend their activities. Some researchers have speculated that alien beings could exist outside our normal temporal reference frame, experiencing time at rates so different from human perception that their communications and actions remain invisible to our current detection methods. Einstein's theory of relativity provides mechanisms through which civilizations could achieve temporal isolation from species like humanity. Time dilation effects near massive gravitational sources create natural barriers where time passes at dramatically different rates. Advanced beings might deliberately position themselves near black holes or neutron stars, where gravitational fields slow time relative to the rest of the galaxy. While billions of years pass in normal space, these civilizations could experience only millions of subjective years, allowing them to witness cosmic evolution while maintaining technological continuity. Civilizations operating on extended timescales would develop communication patterns and decision-making processes that unfold over similarly vast periods. Beings whose individual lifespans stretch across geological epochs would have no urgency to respond quickly to external stimuli. Their thought processes might require centuries to complete, with individual ideas developing across timeframes that encompass entire spans of human recorded history. What appears as cosmic silence to us might represent the opening moments of conversations that began millennia ago and will continue for millions of years into the future. The mathematical implications become profound when considering how such temporal differences would affect interstellar communication. Messages transmitted by civilizations operating on cosmic timescales might unfold over periods spanning thousands of human generations. Their information could be embedded within astronomical cycles, planetary orbital mechanics, or the long-term evolution of stellar systems. The content of these communications would only become apparent when observed over periods exceeding the duration of most human civilizations. Time manipulation technologies could enable advanced beings to accelerate or decelerate their temporal interaction with the physical universe according to their needs. They might spend most of their existence in accelerated time states where enormous amounts of activity occur within brief periods of normal time, emerging into standard temporal flow only when necessary. These capabilities would allow them to observe and study younger species like humanity without detection, compressing years of observation into moments of their own subjective time. What we perceive as empty space might actually contain alien activity unfolding in extreme slow motion relative to our temporal perspective. Massive construction projects, interstellar communications, and complex civilizational activities could be occurring around us at speeds so gradual that we cannot distinguish them from natural processes. Astronomical phenomena that we interpret as stellar evolution, galactic structure formation, or the distribution of heavy elements might partially result from engineering projects conducted over cosmic epochs. Mountain building, continental drift, and other geological processes might represent the incredibly slow-motion activities of civilizations operating on timescales that dwarf human comprehension. Their construction projects could span millions of years, with individual components taking longer to complete than human civilizations typically survive. The patient consideration of complex problems over such extended timeframes could lead to solutions and insights that short-lived species cannot achieve. This temporal isolation could explain the apparent synchronicity between our technological development and various cosmic events. The formation of our solar system, the evolution of life on Earth, and the emergence of human intelligence might represent precisely orchestrated outcomes resulting from activities initiated millions of years ago by beings whose individual thoughts require centuries to form and communicate. Our entire recorded history, from the development of agriculture through the current technological age, might represent mere microseconds from the perspective of beings operating on cosmic timescales. The rise and fall of human civilizations could appear as brief fluctuations to observers whose individual lifespans span geological epochs. We might currently be living through an alien civilization's equivalent of a single heartbeat or momentary thought. Advanced civilizations might communicate through messages that require millennia to unfold rather than seconds or minutes. Their transmissions could be woven into the fabric of cosmic evolution itself, with information content becoming apparent only through observations spanning thousands of human generations. These communications would remain effectively invisible to civilizations that have not achieved sufficient longevity or technological continuity to recognize patterns unfolding over such vast timescales. The universe might contain ecosystems of intelligence operating on temporal scales that render them completely invisible to species confined to brief windows of existence. Multiple civilizations could coexist within the same regions of space while remaining mutually undetectable due to their vastly different temporal frameworks. Each species would perceive cosmic silence while actually surrounded by rich, networks of communication and activity occurring at incompatible time rates. However, these temporal theories remain entirely speculative, with no observational evidence supporting their predictions. The concepts rely on assumptions about consciousness, time manipulation, and civilizational development that cannot be verified through current scientific methods. Alternative explanations for cosmic silence might prove more accurate as our detection capabilities improve and our understanding of intelligence development expands. The growing complexity of potential solutions to the Fermi Paradox reflects how profoundly our scientific discoveries have transformed this ancient question into something far more intricate than originally imagined. These theoretical frameworks reveal how much we still don't understand about intelligence and communication across cosmic distances. The scientific breakthroughs of 2025 have provided our first concrete evidence that life might exist beyond Earth, with the James Webb Space Telescope's detection of dimethyl sulfide in K2 to 18b's atmosphere representing the strongest biosignature discovery to date. Yet this potential confirmation of extraterrestrial life only deepens the central mystery of the Fermi Paradox. Government UAP disclosures have added another layer of complexity, documenting encounters with technologies that appear to exceed current human capabilities while providing no definitive answers about their origins. The mathematical certainty that habitable worlds exist throughout our galaxy, combined with complete absence of confirmed alien contact, suggests that our fundamental assumptions about how intelligence develops and behaves require serious reconsideration. The cosmic silence continues to challenge everything